Okay, so let's see the what you call that the first chapter for chemistry. Of course, are still introductions. Okay, so let's see the meaning of chemistry. It is actually originated from the Arabic word called alchemia. Okay, and this chemistry is the field, one of the field of science which study the structure, property, composition. Composition means that the component inside the structure of of the what you call that, of the element, or sometimes the molecule, or sometimes the element of the chemistry, and also the interaction between the metals. Metals are those what I said just now, like your what you call that, your metal, non-metal, okay, atom like sodium, all these things are metal. So in short, every single thing that you can see or you can feel is made up of metals. Okay, so now let's see the chemicals in daily life that we usually use. Normally they are using it in what you call that, the some different sector, like for food industry we use it as preservative, like your what you call salt. Okay, salt, salt. Sometimes we use it of coloring, flavoring, stabilizer. Stabilizer are those that we use, like for example, we make the what you call the what you call that, the like your stabilizer is like your what you call the jelly powder, the powder that we use to make jelly. Normally stabilizer we use it to make something liquid become solid. Okay, and antioxidant normally we use it in the what I call in cosmetic, to prevent the to prevent the your skin from being oxidized. When oxidized, it will how to say, for our skin, it might comes out with a black dot. Okay, so that's why, like when you see like your when you are getting how to say, when some of other metals are like your metal getting oxidized, so it will be more dark. Okay, your rust is dark color, all this. Okay, and also thickener is making something less concentrate become concentrate. Normally we use it for milk lah. Okay, the thickened milk, what you call that, we use it to banjo that Nescafe, something like that, that one. Okay, in agriculture, okay, we use it as a pesticide. Pesticide are those we use it to kill the worm. Okay, herbicide, fungicide. Fungicide is to kill fungi. Hormone and fertilizer. Okay, hormone normally they use it to how to say, to increase the yield. Yield means that the production of the fruit. Okay, and then for medicine we use it for analgesic, antibiotic, antiseptic. Antiseptic is analgesic are those ubat penahan sakit. Okay, antiseptic are like your what you call those liquid that we use to kill the germ. Okay, like your iodine, all this. Okay, vitamin, chemo. Okay, we use it in chemotherapy as well. The radiation. Okay, the radiated substance. And then in other industry, we use it like polymer, plastics, paint and pigment, glass, ceramic, alloy, detergent, and coloring. These are the chemicals that you will see in this kind of industry. Okay, any questions? No? Okay, so jot down this one, the one that I highlight, and this one. This one don't need to write down so many, just pick three. Each category pick three. Okay. All right. So let's see the development in chemistry field and the contribution of chemical technology. Okay. So there are many fields that require the. I don't make it bigger. This is too small. There are many fields that require the knowledge of chemistry to solve the problem. Like for example, the forensic. Okay, they need the knowledge of chemistry to carry out chemical tests and trace the DNA in order to gather the evidence for certain criminal cases. Okay, while the development of chemistry, they will also lead to development of chemical technology. For example, nanotechnology increase the lifespan of different kind of food and help to reduce the wastage of food, which is spoiled by the action of microorganisms. Okay, they are using like other way to additives to improve the lifespan of the food so that it can stay longer. Okay, now let's see some career, okay, that related to chemistry. For example, chemist is among the career that rely 100% of chemistry knowledge. Like for others, there are some others here. Okay, like for example, we have in biotechnology field. Okay, we have biomedical engineer, where it will apply the engineering principle and design concept to build the machinery for medical and biology for healthcare purposes. So biomedical engineer are those engineers to design the biomedical equipment. Okay, biotechnologists, sorry, they will study the use of living cell and bacteria in industrial and also the scientific process. And biochemists, they study the chemical processes in living organism. Okay, then in nanotechnology industry, we have nanotech engineer, where they will learn the new things that can change the health, science, technology, and the environment at a molecular level. Like for example, I forget which country, they have starting to the research on creating a nano-sized robot that will help to clear the blockage of blood vessel. Okay, and then we have a dietitian. Dietitian normally they are the expert in the nutrition. Okay, in human nutrition, who alter the patient's diet based on their medical condition and individual needs. Okay, sometimes we call them as a nutritionist. Okay, but actually nutritionist and dietitian is different. Nutritionists, they study the nutritional value of food, which they will carry out some experiment to calculate the calorific value, how many calories of that food. But dietitians are those who plan your diet, your meal. Okay. Then in pharmaceutical is actually pharmaceutical is actually those we call medical. Okay, we have doctor, which treat patients, pharmacists, they study the medicine, drugs, and their effect. So doctor will treat the patient, comes out with the what kind of treatment they need. Pharmacist will provide the suggestion on the medicine that you need. Okay, then they have lecturer who teach the topics that related to pharmacology in universities. Okay, lecturers are actually the teachers in universities. Pathologists, they study the pathology and examine the dead body to find out the cause of death. Pathology are actually the pathologists are, I don't know how to explain. Let me check actually they are pathogen. Pathologists are those that study pathogen, the cause of disease. Okay. All right. Then cosmetology. Cosmetology are actually the technology in cosmetic. So we have cosmetic chemists. They will formulate the ingredients for skincare product, your personal care, and also the colored cosmetic for manufacturers. They are normally the researchers in each cosmetic company. They will create the new types of product. Okay, and cosmetic consultant, they actually provide the recommendation on makeup and beauty products to customers. Nowadays, normally comes with the what you call those who apply your cosmetic on your face. I don't know what's the name. Okay, we call the 化妆师叫什么？ Yeah. Yeah. Normally the consultant, they were also the makeup artist. They will normally this nowadays those cosmetic consultant normally will are also the makeup artists as well. Okay, in green technology, we have green tech engineer where they will design a machine, all this, and also the green technology chemist where they will study and create a green technology based product. Okay, so any questions? Okay, no one. Then try. Let us see. Okay, try to do this. Can see clear? Okay. Done, all this. Okay, good. So let's see the answer. So let's see. What's the meaning of chemistry? So it's the field of science that study the structures, properties, composition in interaction between the metals. So the example of chemicals in each of the following fields, like for industrial, we have sulfuric acid and butane gas. What's your answer?
In industry, I put glass and coloring.
Okay. And then for medical, we have antacid and vaccine. Yours maybe use the one that you jot down just now. Okay. Agriculture, we have urea and hormone. Okay, it's okay. You use the one that you get from the what you call just now, the note is okay. So then state the related career based on the job description. Okay, where we have forensic scientists for the which perform the analysis on criminal tools, Then we have study the compound on or element on Earth crust. Earth crust means that the surface of Earth, the first layer, which is geologists, and the bacteriologists study the bacteria. Do you do it correctly, this one?
C, bio.
Biochemistry cannot, because biochemistry is too general. They study the general knowledge of biochemistry. It's a bit different. Okay, for bacteria, you need to use this bacteriologist. Huh? Okay. All right. So wait. I think I have to let me do this as well. Wait, Okay, try to do this one as well. Okay, just fill in this carrier based on the answer here. Okay. Jot down the this one questions as well. Means that you have to jot down this one as well. Okay. All right. So let's see the answer. So for the first one, okay, in agriculture, okay, so study the way of growing aquatic organism is aquaculturist. Okay, for medical, okay, treat animal which are ill and injured are veterinarian. Okay, study pathology, I sorry, just now I've mentioned pathologists. While for industry, study the nutritional value of food is nutritionist. Study the use of living cell and bacteria. This one is biotechnologies. In education, teach chemistry, blah, 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 in university, college, and matriculation are lecturers. Correct? All correct? Huh? Good. So let's see the 1.2 where we will talk about it. Let me check. I think there are quite a lot. Okay, so let's see 1.2. Scientific method. So scientific method is a systematic method that we use to solve the science-related problem. Okay, the method is called scientific method. Okay, so the what you call it? These are the steps in scientific method. First, making observation. Then we make inference. Inference are actually the answer to your observation. Okay, so normally in inference, okay, we will correlate, what I call that, correlate between the manipulated variables with the responding variables. Okay, then we identify the problem. This is where problem statements comes in. Then we make hypothesis. After that, we identify the variables, which is manipulating, responding, and constant variable or fixed variable. Okay, after that, we control the variable. Okay, control the variable means that we control the manipulating variable. Like for example, remember yesterday the pendulum case. What we manipulating length of the string, correct? So like this is how we control the variable, and then we plan the experiment where the experiment procedure comes in. After that, hmm, okay, why suddenly? Okay. Then, after the experiment procedure, we will go for collecting the data by planning the table. Then we interpreting the data by drawing out the graph and chart. Then we make the conclusion, and then finally we write the report. So these are the steps involved. Okay, can I? Okay, so try to jot down all this, the highlighted one only. Okay, then the red color one you need to maybe you give a what you call that? We call give the what you call bracket. Okay. Okay, huh? All right. So let's continue with the how to say the. I mean, we are trying to explain each of the step lah. Okay. So the first one, making observation. So the scientific method we begins with making observation, where the information are gathered by using the senses like your sight, hearing, smell, taste, and touch. Then inference. Okay, inference is made, but it may not be true. But remember, for your exam, it must be true. Okay, so the inference will use the collected data and past experience to draw an early conclusion and make the explanation of the event based on the observation. Remember, you need to write the relationship between what for inference? Manipulated variable and responding variable. Okay, then we identify the problem where we will formulate a questions based on the inference that have been made. We call this as, just now what you jot down is for in identifying problem. We call this as problem statement. Okay, this one. Okay, then after that we make hypothesis. Hypothesis is used to verify the inference. So it's a general statement to relate a manipulated variable and a responding variable to explain the questions that have been asked. So that's why, remember, for inference, normally we will say manipulated variable will affect responding variable. And this hypothesis we will mix up with increase or decrease manipulating variable, increase or decrease responding variable. Okay. Now, after that, we will identify the variable. So where we will have manipulating variable that we use to purposely change during the experiment, something that we keep changing. Okay. Then we have responding variable, which is response to the change of manipulated variable. While fixed variable are factors which are kept the same throughout the whole experiment. Okay, you will keep the same value. All right, so now, number 8, we control the variable, where we will decide on how to change the manipulating variable so that we can measure the responding variable and keep the fixed variable. These are what we do while control the variable. We need to decide before the plan of experiment so that after you control the variable, then we will come out with a experiment procedure. Okay, then planning an experiment. So we need to determine the apparatus and material use, the procedure, and the way to collect, analyze, and interpret the data. Then we will carry out an experiment, okay, to test whether the hypothesis can be accepted or rejected. Okay, again, in SPM, your answer must be accepted. The hypothesis must be correct. But in your later on, when you go to university, right, some of the experiment are allowed to miss because not all experiment must be correct, the hypothesis. Okay. Then we need to collect the data where we will use observation, measurement, and also the record, all the data. Okay. Then interpreting the data where we will analyze the result or data collected and interpret them through the calculation, table, graph, chart, all this. And finally, we will base on this data, we will do a conclusion, where the conclusion is actually we draw a general statement about the outcome of the experiment. And we need to use the accepted hypothesis, which will become a theory. So a new hypothesis will be constructed if hypothesis is rejected. So like I said, the hypothesis must be true in the end. And finally, all these things will be write into a report. So inside a report, you need to include aim, problem statement, hypothesis, variables, materials, apparatus, procedure, observation or result, analyzing and interpreting data, sometimes with discussion. See, graph, chart, and discussion. Okay, observation normally is table, and finally conclusion. So jot down that only the 40. Okay, only this one. Jot down a number for 2 degrees. Done, huh? All right, so let's just see the one of the experiment. So we want to study the effect of temperature on the solubility of salt in water. So you know how you write aim is normally we start with to study, to analyze, to investigate. This is how we start the sentence for aim. Okay, so for the problem statement, does the temperature of water affect the solubility of salt in water? So the hypothesis, the higher the temperature of water, the solubility increase. Normally we are higher, the higher. Okay, I don't like the way, so normally we are the higher of the temperature of salt, the higher the solubility of salt in water. Okay, so the manipulated variable, this is the one, so the temperature of water. Responding variable will be the solubility of salt in water. So fixed variable will be the volume, mass of salt, and also the time taken, the time that we calculate. Okay, so the material are the things that we use, like distilled water and salt. Then other, like the equipment thingy, right? We put it in apparatus, like beaker, measuring cylinder, thermometer, electronic scale, glass rod, Bunsen burner, stopwatch, wire gauze, and also the tripod stand, sorry. Okay, so let's see the procedure. We add 50 cm cube of distilled water at the temperature of 10 degrees Celsius. Is measured by using a measuring cylinder, and then we pour it into a big what I call the beaker. Then 10 grams of salt we add into the beaker, and the solution is stirred by using a glass rod for 2 minutes. then the solubility of salt is observed. Then we repeat the experiment, okay, with temperature, the water of temperature 30 degrees Celsius and 80 degrees Celsius. And then we record down the observation. So these are the results. When 10 degrees Celsius, there are many salt still does not dissolve. 30, almost all. And 80, all of the salt will dissolve quickly. So normally what we do in interpreting data, we will need to discuss on first, precaution. What is the precaution step? And second, sometimes we will mention about the what you call that, about the theory behind this. So like for example, the relationship between the temperature and solubility. So temperature increase, solubility increase. So, and this one is precaution or modification. Modification is something to improve the experiment. So what kind of that? So that it can, the 30 degrees Celsius can dissolve more quickly by increase the volume of water. So with this, this will give you another way of doing the experiment where there are two factors that can control this. One is volume of water, one is temperature of water, which will affect the solubility of salt. Can you understand? So in interpreting data, right, we are not just mentioned about the graph or the what you call that, the result of observation only. We will also mention about, like I said, precaution, modification, and the theory behind it. Sometimes, okay. So in short, conclusion, hypothesis accepted. So the higher the temperature of water, the higher the solubility of salt. Okay, can I? All right, so let us see with the second one, this one. Okay, try to do this. Okay, so let's see the answer. Wait, okay, so let's see. So the scientific method start with making observation. So based on the observation, we will make an inference, but it may not be true. And to verify an inference, we need a hypothesis. And an experiment is carried out to test whether the hypothesis can be accepted or not. Okay, so this is pretty easy. So let us see because I want to check. Okay, maybe we can just continue on. So let's see the next one. The usage, management, and handling of apparatus and also the chemical materials. So it means that we are going to go through a bit on how to use the apparatus, lab, and also some of the chemical. Because some of the chemical might need special treatment, but this one we only just mentioned a bit. Along the class, when we keep going deep and deeper, so we will go through, we will start to have more, you will learn more special treatment chemicals. Okay. Now, the lab is an important place to study the chemistry. So it can be dangerous if the rules and safety measured in the laboratory are not obeyed. So let's see the three main laboratory rules. Okay, three laboratory rules. First, do not eat or drink in the laboratory. So second, start the experiment only after getting the permission from teacher. And do not pour back excessive chemical into the reagent bottle. So let me explain to you why each of them. First, why we cannot eat or drink in laboratory. As we know, some of the chemical are actually exist in terms of gas. And some gases are like chlorine, which is actually quite deadly if high concentrated. Let's say when you put your water or food inside the laboratory, suddenly there's a chlorine gas leak. So those food might be contaminated. And if you don't know, someone eat it, it will cause death. Okay. Second, why we need to get the permission from the teacher? Then we start the experiment. Because without the permission from teacher, there will be no one to look at you or to take care of you during your experiment. So anything happen, the response might not be on time. Okay. And this is the most important one. We cannot use the excess chemical and pour back to the reagent bottle. For example, the bottle is, for example, for sulfuric acid bottle, sulfuric acid bottle. Then after you use it, there's an excessive, you want to pour back, is it correct? Wrong. Why? Because when you are doing the experiment, the reagent that you use might be contaminated. Means that you might have accidentally add something inside. It's no longer pure substance. So when you add back to the reagent bottle, that whole bottle will now become impure element. You understand? So this is to prevent or to make sure that the reagent in the bottle still remain the same. Okay? All right, so jot down this one first.
Yeah, yeah.
Done, huh? All right, so let us continue with the next one. So the three safety measures that we need during in laboratory. First, do not point the mouth of the test tube at your face or at other people. For example, when you hit the naphthalene, you know it's naphthalene, the thing that they use in the toilet to make the, which will release the what you call the smell. The yellow color one they put in the toilet, that one is actually made of naphthalene. So when you're heating it up straight away with, let's say if you don't know, you just hit it straight away with fire. So it will actually not explode, is volatile. So it means that it will like pancit telur or something like that. So if you face that to people or to your own face, you will get, because it's in high temperature. So when you hit with the explosion, you might get hurt. Okay, it's very dangerous, especially those what you call that, the naphthalene, because when it punches keluar, it's in very high temperature. It will cause until level 2 burn. Okay, it's very important to know this. So that's why we cannot point the mouth of the test tube to you and or other people. Then sometimes mixing or heating the chemical, you have to wear safety goggle. Why? For example, sodium, not sodium, no, potassium, I think. Potassium element, potassium is very highly volatile element. When you place it in water, it will like dancing around. In high temperature, the temperature might almost hit 1,000 degrees Celsius on that time. So if you didn't wear safety goggle, it jumped into your eye, gone. 1,000, almost 1,000 degrees Celsius. And also for those experiment which involve the release of toxic gas, you need to use a fume chamber. Fume chamber is actually a box, okay, a cupboard with a small box at the middle and what you call the air sucker at the top. Where when you do those experiment with toxic gas, the air sucker will suck up the air and go into the filter. Okay, so this is why we need the fume chamber. Okay, okay, jot this down.